My dear students, in this video I am going to define a discrete random variable. It is given in the topic number 11, probability distributions, which is in your 12th standard state board syllabus. And this topic is also you can find in CBSE also. Now, in the previous video, I have defined random variable. In this video, I am going to define what is discrete random variable. You know, random variable is a real valued function from x, is a random function which is from S to R. You know that x is the random variable is a real valued function from S to R. You know, S is the sample space of an experiment and which is assigned the real values in the set R. And this function x is called random variable. Discrete random variable means, so in the random variable x, the elements of the sample space are associated with the real number sets R, and the range of the real number set R consisting of only countable number of elements, that is finite number of elements. So in the real valued function random variable x consisting of only countable number of elements in the real valued function R, then that random variable is called discrete random variable. That's all. In the range set R, you will get only finite number of elements. That's why it is called discrete random variable. So that is the definition I have written in the blackboard. See, a discrete random variable. A random variable x is defined on a sample space S. A random variable x is defined on a sample space S into the set of real numbers R. A random variable x is defined on a sample space S into a real number set R, set of real numbers R, is called a discrete random variable if the range of x is countable. If the range of x is countable, that is, R consists of finite number of elements only. Every finite value in the random variable, every value in the random variable x has positive probability. In the random experiment x in the sample spaces, every random variable x has a value you know. This is the random variable values which has solved in the previous video. That is, we know that on tossing 3 coins, we consider the random variable x as the number of hits appear. On tossing a coin, tossing 3 coins, random variable x is the number of hits appear. So the random variable x has a real value 0, 1, 2, 3. That means there is no head, 1 head, 2 heads, 3 heads. That is the values of the random variable. So each value of the random variable has positive probability. That's one definition. In this definition, we are now come to the probability of each real value. Each value of the random variable, if there is no head, 1 head, 2 heads, 3 heads, and each value associated with the real number 1, 3, 3, 1, 8. Sorry, total 8. 1. No head. There is no head. It is associated with the number 1. Real number 1. 1 head associated with 3 because in the sample space you know 1 head is 8 elements you have totally HH, HHT, sample space consisting of HHT, HT THH, and TTH, THT, HTT, and TTT. The 8 elements you have. No head means this case 1. It is assigned the real value 1. 1 head is 1, 2, 3 values. 1 head assigns the real number 3. 2 heads 1, 2, 3. 2 heads also assigns real number 3. 2 heads also assigned real number 3 because 3 outcomes in the sample space, and 3 heads is the only one event, therefore 3 heads assigned real number 1. So 8 real value has a positive probability in the discrete random variable form. For that, I define the probability of no head. Probability of no head means I define by probability of x equal to 0. Probability of x equal to 0 because this is x. Probability of x equal to 0. Okay. What is probability? Number of events for x equal to 0 is 1. Total 8. Therefore 1 by 8. 1 by 8. And the probability of one head. One head assigned to the real number 3. Total value is 8 in the sample space, therefore 3 by 8. So probability of one head is probability of x equal to 1 is 3 by 8. Similarly, probability of two heads. Two heads assigned real value 3, therefore this is also 3 by 8. And probability of 3 heads, that is p of x equal to 3. So 3 heads occur one time, therefore 1 by 8. So each the real value in the random variable has positive probability. These are the positive probabilities. You can now consider this as a table. See, now we will consider this as a table. We will see now. Okay. Therefore, the random variable for three head, number of heads occur. The real values of the random variable x are 0, 1, 2, 3. Their corresponding probabilities are defined by f of x, that is 1 by 8, 3 by 8, 3 by 8, again 1 by 8. So this table, on tossing 3 coins, the number of real values of the random variables are 0, 1, 2, 3. 0 head, 1 head, 2 head, 3 head. And they are associated with the probabilities for 0 at p of x equal to 0, 1 by 8, p of x equal to 1, 3 by 8, p of x equal to 2 heads is 3 by 8, and 3 heads is 1 by 8. This table is called probability mass function or probability distribution. This table is called probability mass function. Probability mass function or probability distribution. So now I am going to define what is probability mass function. Just give an example for probability mass function first. Tossing 3 coins, and x is a random variable, that is number of heads appear. The real values of the x are 0, 1, 2, 3, and the corresponding probabilities are this. This table forms the probability mass function. Otherwise it is called probability distribution. Now I am going to define what is probability mass function. Probability mass function, that is, if x is a discrete random variable with the positive values of x, if x is a discrete random variable, if x is a discrete random variable with real values x1, x2, x3, etc., xn. If x is a discrete random variable with real values x1, x2, etc., xn, with their corresponding probabilities, with their corresponding probabilities. Corresponding probabilities f of x1, f of x2, f of x3, etc., f of xn. See, if x is a discrete random variable with the real values x1, x2, etc., xn, and with the corresponding probabilities f of x1, f of x2, f of x3, like that. These are the real values of the random variable x, and these are the corresponding probabilities like that. And the function f of x is said to be probability mass function if it satisfies the following properties. That's all about the definition of the probability mass function. If it is the case, then we can find then the function f of x is said to be probability mass function. F of x is said to be probability mass function or probability distribution. Probability mass function or probability distribution if it satisfies the following properties. First property is each XI each probability f of xi is positive where I equal to 1 to etc. n. Each probability is positive, and second one is sigma I equal to 1 to n f of xi equal to 1. Total number of probabilities of the items are 1. If it is the case, these two conditions are satisfied by the function f of x, then that f of x is called probability mass function or probability distribution. In this case also, if you add all the probabilities 1 by 8 plus 3 by 8, in this case also you can add 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8 equal to 8 LCM 4, 7, 8, 8 by 8, that's equal to 1. The condition is satisfied. Each probability is positive and sum of all the probabilities are 1. These two conditions are satisfied in this example. Therefore, this table is called probability mass function or probability distribution. This is the example for probability mass function, and this is the definition. A function is said to be probability mass function if each probability is positive and sum of all the probabilities are equal to 1. Okay? Next we will see the definition of cumulative distributive function or distribution function. Cumulative means accumulated distribution function or distribution function. See, you know the probability mass function as take the random variable x as real values x1, x2, etc., xn, and the corresponding probabilities. So you know the random variable x has the real values x1, x2, x3, etc., xn, and the corresponding probabilities, you know, f of xi equal to f of x1, f of x2, and f of x3, and so on, that is f of xn. So in this case, if you cut short the adding that probabilities successively, that is called cumulative distribution function. F of x1 plus f of x2 plus f of x3 and etc. some scale f of xi. Up to this stage, you will consider that f of xi is assigned to x, and sigma summation of all these probabilities called cumulative distribution function, and it is going to be capital F of x. That is, the cumulative distribution function capital F of x of a discrete random variable capital X taking real values c, x1, x2, etc., xn, and the corresponding such that each x1 less than x2 less than x, etc. less than xn, x1 less than x2 less than xn, and so on. And the corresponding properties are f of x1, f of x2, f of x, etc. f of xn. That is, the probability mass function f of xi is, this is probability mass function. This is probability mass function. In this case, the probability cumulative distribution function or distribution function is capital F of x is defined by probability of x less than or equal to x, such that sigma xi less than or equal to x, f of xi, where x belongs to R. That is, cumulative distribution in capital F of x is sigma summation of the probabilities up to some xi, up to some certain state, f of xi. Summation of all these probabilities is called cumulative distribution function. That is nothing but sigma xi less than or equal to x, probability of x equal to xi, where xi belongs to R. In this case, some stage, up to some certain stage f of xi, you can add all these probabilities. That gives you the cumulative distribution function of the random variable x. That is denoted by capital F of x. That's all the definition. We will continue the problems in the next video. Thank you.